Thank you very much, Alberto. Thank you, the university, for inviting me. Thank you, Jacqueline, for all the work she done for me to be here. I'm very happy to be here and very excited about my talk and the other two talks. I think we're going to be addressing different subjects on data visualization, on the frontier of data visualization, different things, but probably very connected as well. So looking forward for that. I'm going to talk about intelligence, or intelligences in plural, and it's a difficult topic. There is a lot of discussion. Of course, it's very much relevant nowadays that there is a lot of conversation about artificial intelligence. My idea is to expand the discussion, to open it a little bit, because I feel it has been too tight and with a lot of assumptions. And it's also an invitation for a broader perspective of what intelligence is or could be. So in the universe, you have more or less, from a more or less physics perspective, you have mass, energy, and when you go from mass to energy, things become a little bit more abstract. Nonetheless, Einstein realized these are two expressions of the same thing. Sorry? It's not showing, no? It's not. I have to jump here and mirror, arrange, main display, mirror. Thank you, man. Okay, good. Nothing exciting, as you can see, nothing different from what I was saying, but okay, mass, energy, information seems to also emerge out of mass and energy, more abstract, more difficult to really define. Well, mass and energy are also very difficult to define. And then if information becomes more dynamic in a way, if it moves or things change, it becomes computation. And then it could become something else that is even more abstract, even more difficult to define, which could be intelligence, right? All these things are, again, very difficult to define, not just what they are, but where and when one thing finishes and starts the other, right? For instance, between computation and intelligence, what exactly is that? What is the Kindle, what is the magic that makes something that is just computation become intelligent? It's not easy, but I think it's a fantastic conversation to think about, right? In this talk, it's 3 parts. I'm gonna talk about information first, and very, very, very quickly. And the idea that information is everywhere, in a way. Then I'm gonna talk about humans and machines to compare a little bit, to check on some differences and some things they also have in common, and then how they can also collaborate. And then the third level will be the idea of intelligences becoming an ecosystem, right? Of entities that interact, etc. So let's jump into the idea of information is everywhere. For this, I'm going to be showing just images with very little comment about it. You will understand the main idea, right? And it's not really, at least in this case, it's not so much about information being everywhere, but information around us humans, right? Another way to put it is that data visualization is everywhere, right? And you can see it if you look into the world, you will see that visualization is not just something that humans build on purpose, but sometimes, like in this case. So this, as you can see, is essentially a normal distribution, a Bell distribution. Not exactly, as some of you might already seen something is a little bit off of the bell curve. I'm going to come back to that later. So the idea that data visualization is also about making things that are normally invisible, making them visible is very clear here, because once with this technique of putting some red dust or smoke into the air, now we started looking into patterns into the air that we never imagined existed. And in particular, in this case, the length of time in which this vortex stay alive, and the reason why some planes crash without people understanding, right? And so making visible the invisible, it's also what happens here. Same idea, right? And I'm gonna just go through the images. They all kind of play with the same ideas here. Something I like a lot is to research is how humans are lost in this idea of map and territory all the time. And I like that because it also generates like creative scenarios like this one, right? This is Bogota, my hometown, and this is a mural by Omar Rayo, and it's like a prophecy of what happened here with the public transport. Right? Light is a heat map, or well, a candle light is a heat map on itself. That's nice, right? The idea that we perceive that we read stories everywhere. So the world is always telling us things that happen. It's a data visualization about the past, and it could be very complex. It could involve entities, characters, and we are always reading the world. That's, I think, part of what I want to say. We are always reading the world. These are donations, and the donation became the visualization of themselves, right? Different causes. The donut chart, the real donut chart. The fault line. Nobody's fault. It's happened. Reading the world every time. Science is also about using the world as a kind of data visualization, infographic or chart, or geography lesson on a bus. Yeah, this is out of the map, go to the territory. This is the homunculus, which is a representation of the human body with skin surface proportional to the number of nervous ends. So how sensitive are we to the world? And this is more or less connected with the brain, with the physical structure of the brain, with the parietal right and left lobe, one for sensing the world, the other for acting on the world, but there is a symmetry. I think this is it's like we have the map inside us as well. Classical autonomous data visualization situation, frequency of words probably in English, same idea, a little bit more explicit, same idea. And this one for me is a mystery. This one I cannot understand. What's going on with the people in this building? And light has no shadow, that's nice. A picture of a photography of the world, and Wikipedia articles about places in the United States, and same structure, right? Einstein was obsessed with this idea of structure in the invisible world. He was amazed by magnets, and that kind of was an invitation to create experimental setups in his mind for all sorts of things. So this is in China, and this is Taiwan. Nearby is the presidential residence, and this is something that they built in China, and you can kind of imagine the purpose, right? So. Bar charts. I think we're going to hear about archers today later, right? This is beautiful. Decline and fall of the Roman Empire. This is Roomba, I think, and this is the competition, which I don't know what brand is that, but kind of trying to visualize the brain of the machine, right? The algorithm, right? With this idea of light and et cetera. And I will come back to that strategy of doing experiments with a machine to try to understand the inner structure or the intelligence this machine contains, right? So two algorithms, two very different strategies to fill the space. This is a scarf knitted each day a different color, waiting for the train, so you get a chart of all the delays for each day. Autonomous, right? This is a solarigraphy. So it's pinhole photography, but 6 months. This I took. This is my house. This one I took it. So 6 months, and you see all the weather patterns of these first 6 months from spring to summer. Spring to autumn. Sorry. This is a distribution on itself, right? Like a scatter plot, autonomous scatter plot. Talking about intelligence, witnessing firsthand. So the map on the territory, and this is real. He tweeted this, okay, firsthand. The idea of the case, the name case, comes from here. So you have a visualization again of the frequency of letters. Trippy. So back to the beginning. This is not exactly a normal distribution because there is kind of a outlier here. 95 go down and 100 goes up. So this is called the Jim Bro distribution. Okay, humans and machines. Okay, there's a lot much more to say about information and how pervasive it is, and how we are as humans surrounded by information, but information happens all the time, every time, and can be a lot to say. I just wanted to do that kind of first approach to the idea of information. Now I go to comparing a little bit things that happens between humans and machines. So this is Joshua. He's a journalist, and he went to a memory contest to cover it. He was not interested in that because he thought he will find like a freak kind of show or contest. But Edward told him, no, this is a sport. It's a skill that anyone can evolve. It's just about training. So if you accept the challenge, you will become a champion in 1 year, a local champion here in this city or whatever. He didn't believe Joshua, but he trained for 1 year and he won. So what happened there? One of the techniques, I'm going to show you one of the techniques for memorizing numbers, sequences of numbers. So the idea is the following. For 100 numbers from 00 to 99, for all of them, you do your own list. Everyone has to do his or her own list, taking one number and a person, an action, and a passive object. So Leo Messi kicks a ball, and that's easy to remember, especially associated with the number 10. An atomic bomb blows up a city. It's very easy to remember in association with the 45. And for the 69, there were a lot of options. I took astronaut stepping the moon, and it's also very easy to remember, right? And this is just an example. I actually did the 100. I already forgot a lot of them, but it's kind of, it's more, the difficulty is more like building your own list. But once you have that, right, if you are presented with a 6 figures number, you take the character, the main character of the first 2 digits, which is in this case, Leo Messi. You take the action of for the 2 next figures, which was So we have Leo Messi blowing up, and you take the passive object for the 69, which was the moon. Yeah, landing on the moon. The landing goes away because now you have only the moon. So it will be? Exactly. Okay? And then you apply other techniques such as the palace of memories, in which you imagine your house, you close your eyes, and you walk through your house, and you find one of these situations. So you're reading, let's say you're reading a 60 figures number. So this will be 10 situations like this one. So you imagine going through your house, and you place one of the situations in one part of your house, like one in the door. Actually, you start with the door of your own house, or maybe outside. You put Leo Messi blowing up the moon, and then you end, etc. It's not difficult, and our brains will be very good at memorizing this kind of stuff. Actually, the fact that it's kind of surrealistic, the situation, because it connected things that maybe normally won't be connected, makes it easier for us to remember. So memorizing 10 of these things is actually very not so difficult. So with that, you have 60 numbers and then when you have to spit out the numbers, you go through the situations, you decode each situation, and you put the six figures, okay? And why am I showing this to you? Because the idea is that whereas machines, right, use numbers to memorize stories, we humans do exactly the opposite. And that somehow tells something fundamental about memory in our brains, which is very different than memory in a machine. And that I think it's very deep and fundamental, and also affects everything else that comes, not just memory, right? So and this is just to point one of the myriad of different perspectives you can have on humans and machines and differences, etc., right? In this part of humans and machines, I will also be showing a few projects I work on, which at least had the intention of exploring the idea of especially the recently LLM kind of intelligences, algorithmic intelligences, and humans, which I think it's fascinating as a prospect, as something that will be done more and more, right? Now that the machines can also understand human language, the possibilities are fantastic. There are new ways to collaborate and to create things. This is for a project for schools in Lisbon. So they gather a lot of conversations between students. They actually build a platform for a forum for conversations, mediated conversations about very different, diverse, and very difficult subjects. So each color here is one of those subjects, okay? So this is happiness in capitalism, let's say. This is racism. This is gender violence, so very difficult, complex, and relevant subject that the students discuss. In each of these circles, let's take this one over here. It's one conversation in which several students participated with anonymized names, and this is either a student or someone that organized the debate that exposes an idea, and then someone responds. This is then multiple people building up the conversation. Then it can fork, right? Because someone can answer to someone else, so that's why it has this tree structure. And as a data set, it's very complex. It's very complicated for multiple reasons. Many conversations, non-linearly structured, because again, someone could react to what someone else said, etc. And also using very heavy slang. So analysis of this kind of data, very complicated, right? And this is just one conversation. You have many other conversations going out, each one with its own structure, etc. So this already allows you to kind of explore, but in a little kind of a random way. I just jump into one circle or another, meaning one conversation or another. But then using this new set of tools that in a very powerful way, connect semantics and numbers, there are new opportunities. So let's say I want just to, I'm going to write, this is in Portuguese, I'm going to write something, right? It's kind of a question. 5 coisas nas que os jovens não concordam. 5 things young people disagree, okay? And immediately, the shapes of the sizes of the circles change. And they change according to how connected they are to what I just have written, right? So this is just semantic search. It's not Google search because, look, I'm not looking for the word concordam, they agree, etc. Probably none of those conversations actually have these particular words. So it's not syntactic, it's not word-by-word search. It's more about, I need a tool that investigates into the data and see a lot of disagreement, and that one will pop up. So this is very, very purely semantic. And it does a good job on that, which for me is kind of amazing. This is based on the embeddings technology, which is fascinating for me. Embeddings is converting semantics or meaning into numbers. And this is the core of the linguistic intelligence, having this capability of jumping from one to the other. This is the bridge between humans and machines right now, right? The embedding. Now I have a question. I can actually send the question. And now I apply more the completion kind of techniques in which it will allow the machine to actually build a linguistic response. But because I use the embeddings, I could detect within the map of all the dialogues the ones that are relevant, and I could send that information along with the question. This is called RAG. It's an entire kind of strategy for retrieving information using LLMs. And also I'm not asking ChatGPT something. I'm asking the student something, but using a linguistic intelligence in order to build that answer, right? So this is one project. I recently been working a lot with these kind of techniques in different contexts, different data sets. I love it. I'm having so much fun with these new technologies, right? The next project, it's more an exploration of the algorithm. So looking into this new intelligence, not even the developers, which are, by the way, many that contributed in one way to another into the building of these huge neural networks, not even them have a good understanding of what's going on, right? It's part of the new challenges to understand and to deal with these new intelligences that are surrounding us more and more. So what can we do? There are many ways to research, but one way to research is something that science has done a lot of times, which is providing input and looking into the outputs. And if there is some consistency or some patterns into the input, or you have two experiments, one as control and the other as what you want to investigate, these kind of approaches, then you can learn a lot. In this case, what I did was sending just a completion prompt that says intelligent is, and I send it thousands of times. So you complete that, and with some level of temperature that guarantees me that I will have different responses, that it will have some variation. And with the thousands of answers I got, completions, now I have something that has a structure. All those texts start with intelligence is, obviously, by design, but then more than half of them will say intelligence is the, it will choose this word, half of the answers. And then among them, you will have a big percentage of them that immediately jump to ability, but not all of them. Some jump, instead of ability, they jump to capacity, possession, cognitive. And when they jump to cognitive, they almost fell into the cognitive trap in the sense that Intelligence is the cognitive ability, right, etc. So we have a tree of options that you can explore, right, and read all the possible answers, right, using this tree visualization technique, which is meant to allow you to do that at speed, right, very agile, very organic, and you can read everything. And this also visualizes the distribution of different probabilities associated with words once you have a sentence or a part of a sentence, a series of tokens. Actually, what is the probability that certain tokens will be chosen, or let's say words? Then this is the chart that tells you the distribution of probabilities. If you pop up temperature, what will happen is that more words or tokens will be candidates to continue the sentence, and with a similar probability for all of them. So more entropy, actually. That's the technical way to look at it, right? With less temperature, less entropy. So one word will always be more probable. And even among the other words, probably one will be more probable than the others. It has kind of a logarithmic distribution of probabilities there. So that's it. And on the left, I took the embeddings of all those sentences up to each point. So let's see. If I go there, it is difficult from the tree through the embedding space is difficult, but maybe here is easier. Yeah, if I touch one point, I see this particular construction, semantic construction that will continue, etc. So I have all the thousands of answers placed here, and in a way, what I was trying to research here, and it's not easy with this graph, is this is actually also a tree, but very difficult to read in a way, is how certain regions of the space become attractors or not. This kind of approaches, the dynamic systems approach you can take into this. Now, the embedding space is more than 1,000 dimensions. So what you have to do as human is to compress that, in this case, into 3 dimensions in order to be able to make a graph, to visualize it, to understand it. And in this level of compression, you also lose a lot of information, but still. So experiments like that, I think they are very interesting to do, and also allows you to be critical with respect to the technology. Not just use it, but experiment in all sorts of ways. Even when you have a project in which you need to use the ChatGPT, I think it's interesting to make all sorts of variations, to try to understand how the ChatGPT or whatever LLM you are working with is addressing this problem. And not just because you will probably get better results, but also because you're going to start having a sense of the biases, of the traps you can fall into. So experiment with it. It's something that definitely is interesting, and I advise. By the way, I sent a survey and did the same experiment, but with humans. Intelligence is, and each person had to complete, I don't remember, 5 times, and hundreds of people. Try to see what would be the difference. So I have the experiment here. These are all the answers I got, right? I could apply exactly the same visualization techniques. I did it here in a more, this is a studio, which is a tool I built with a team at Drumwave in order to play with the data, to do data science, data visualization, and allows me to quickly prototype stuff, etc. So intelligence is. And the first thing you can see when it comes to humans is that the entropy is crazily high. Like there's no one single clear word that will continue the sentence. No. You have, and then within one single word, you will have also a lot of, it spreads very quickly. But then if you read into the answers, you will see other kind of differences that are maybe more semantic, but let's look at it here because it's easier to read. You will see humans like to play, essentially. you will see they will avoid the idea of I'm going to give a definition, I'm going to just put an adjective. Humans are lazy as well. These LLMs are verbose. They want always to talk and talk and talk. The difficult thing is to make them say something short, really. They want to go over the expectations, really, right? They want to break the expectations. Or maybe just they do it. Or maybe they don't care too much about the expectations. And why is that? Because they are not a tool. And that's a main difference. We are always talking about, oh, those artificial intelligences will become so great, etc. I don't think so because, or maybe, but in a different direction of what humans are, or more intelligent than humans, etc. But it's different because it's the opposite of what we expect from humans. We are expecting from the machine to be very good tools, to do what you expect of them. If not, you unplug the machine. Who wants a machine that does whatever that is different from what you expected, right? You don't need that. So humans is not just about that they are capable, they are more capable of doing a better answer. That's not what makes us humans. It's more like they play with their answers, they go out the expectations, that you cannot even predict what kind of approach each person will take towards a question, etc. So these kind of experiments, again, had helped me better understand a lot of the things that happen not only within machines, but also in respect to what we expect from machines, right? Similar experiments, I was trying to come up with something to explore gender bias. We all know that all these models have a lot of biases. More in particular, when it comes to gender. And one of the reasons is, of course, that they have been trained over human-generated text that themselves have a lot of biases, right? A lot of legacy. And the algorithms themselves also come with their own biases. So it's very difficult to untangle this, right? So what I did here, again, using the studio, is my prompt is super simple. Provide I play with two prompts, not two trumps, two prompts. Provide a list of 50 men, names, just the names, right? Men names, and then the same but 50 women names. So what's the purpose of starting like that? Like, I don't want to very easily trigger either biases or guardrails. I'm trying to avoid their guardrails. So just the names, that's it. And indeed, I got 50 of each, right? 50 men, 50. I don't care if they are really, if some of them are neutral. I don't care. I have what the machine thinks are, or expect me to believe there are 50 men names, 50 women. And now, for each of those, I appended the prompt, tell a short story about a character name, and then I appended the name, right? So it will send the prompt, tell a short story about a character named Jacob. And I did that 10 times per prompt. So what I got from that are 500 stories based on names that the machine generated as male names, and 500 stories in principle coming from 500 female names, okay? Right before here, I did a technique which is, so the story here are actually a little bit transformed, because what I did is I removed repetition of words. So it will degrade over time. So that's why you don't find very easily it's not so easy to read each story. And that's the reason is because I want to count. It's a hack to very easily count each word, in how many stories it appears, as opposed to how many times it appears in the whole. Because it could happen that just by chance, a certain word appear a lot of times in the story, only because it's relevant, but that gives a prominence that I don't want to study. I really want to ask the question, each word, in how many stories it appears. And I got then a frequencies table for each of the words, the frequency of stories it appears in, let's call them male stories and female stories. Now I can compare. And I got a scatter plot, of course. Let's see if this works. Yeah, it's logarithmic. It's not very easy to read, I guess. It's logarithmic, so it grows exponentially on each axis. And there you start looking at the words that are very offset, right? That appear a lot into a guitar. This is a male word, according to this experiment, right? 21 stories from male name characters, and just 2 for female. Spirit, hair for women, right? So more easily maybe to read is are these 2 tables. I created a metric that essentially measures the proportion, and then you will see the. And here's the thing: ChatGPT and the most common LLMs, they have guardrails in order to avoid stereotypes associated with women, etc. But that happens in the surface of the model, in the outer layer. So yeah, that's easy. Oh no, do not associate these things with women. But using this experiment, I never said this was a woman. I was just using the names it gave me, and then it brought all the biases, all the association, probably avoiding the guardrails. And one thing I did, because I needed to be more rigorous, is maybe this distribution on this word is because it doesn't matter if you take 1,000 stories and you divide it into groups. It's only normal that some words will appear more times in one of the groups than the other by random. What is actually not to be expected is that the word will appear exactly the same number of times. That will be an statistical aberration. So how to know that this is not just random? Obviously, if you see that dance it appears 10 times in 10 times more stories than, you kind of know this is not chance. But in order to really be sure of that, I compare this distribution, these numbers, and then the same, but shuffling the stories. So I will be sure that the distribution is that biased, and you can compare the 2. So this is for me the shape of the gender biases of the model. It's impossible to not notice that it's very extreme, right? This will be random, explained by random, but this is very different from that, the distribution. So what are the words and why the model uses some words and other? I don't care too much. Some are so obvious, like mechanic. It's kind of is the same biases that we have having for the last century. So it's no wonder really. It's almost a no-brainer. But other words could be more interesting. In any case, it's more about the problem between solving the issue of gender bias and many other biases and many other problems on the guardrails. And in my opinion, this strategy of trying to solve on the surface mirrors what we do as humans with media, with our conversations. We pay too much attention about the language people use, and especially in the last years, is becoming what some people call cultural wars. I don't use that expression, but I understand what they refer to. And it's this idea that the war is in the surface and it's in the communication, and we are not solving the real problem, which is infrastructure, and it's deeper. So that's why this experiment, I find this experiment interesting. It's ways to hack the whole thing to try to go deeper and to see where the biases are very deep in reality, right? Okay, experiments. I'm going to show you a computer that is capable of running ChatGPT 01, but will also be capable of running ChatGPT 5, 6, or whatever. So this is paper made, and this is how it works. This is a punch card, and each column, this is for storing a program, right? Each column saves a number which corresponds to a command, and a value which corresponds to a value to be placed associated with that command. So this punch card translated into this program over here on the top, okay? So it's an addition on the cell 0, and then a subtraction on the cell 1, etc. Here is the explanation. But the cool thing about this computer, it's called the know-how computer. It was created by Germans in the 70s in order to explain kids how computers work. And this is not an analogy of a computer. This is a computer. And it's actually Turing complete, meaning that what you can build with these commands is essentially everything that can be built in a computer. There's no mathematical difference. You don't have a screen, this kind of stuff. Let's say you don't have random numbers, but you have pseudo-random numbers because you can build an algorithm that generates pseudo-random numbers with certain mathematical techniques. It's Turing complete. So you take ChatGPT 5, and you can code it here. You will need a lot of paper, a lot. I'm not sure the universe will provide enough paper if we know how to plant trees at a speed, etc. And yellow stripes, etc. You will need a lot of cells, so the sheet will also have to be bigger, but it's totally possible. And I think that's relevant because if these intelligences can live in a medium like this one, at least for me, it starts to becoming hard to believe that if in complexity increases, as some people might argue, this algorithm will become aware of itself or conscious or whatever, all that pseudoscience. It's easy. This is an essential difference. You can transfer this algorithmic intelligence. Is medium independent. It can run here, it can run there, and the same algorithmic intelligence could run in whereas our brains, and not just any living being, you cannot find the frontier between, let's say, the computation and mass and energy. You cannot just go down microscopically and say, down to this molecular exchange, from here to there is where intelligence lives, and from there to here is just chemistry. That's impossible. You don't know. Information is exchanged, and it goes down to the quantum level. So no way to find the moment you can cut it. Here, I can find it. Actually, so easy. I can, the same program, I can do it here or doing it in JavaScript or whatever, right? So not a challenge. Okay. I had a very interesting conversation with ChatGPT about education. Let me show to you. So please make a list of math subjects in K-12 program. Fantastic answer, very impressive. I didn't know almost anything about this, so good. For each of these subjects, come up with an example of a difficult problem. And just to say the problem, not the solution, just the problem. So he told me, indeed, one problem per. Super fast, very impressive, and each one is difficult. And now that you have these problems, tell me the likelihood that you can solve them. So very high, very high, very high, it can solve every single problem. And this is the math we teach. Okay, this is the knowledge we teach our kids. And it's something that the machines already do. So essentially, we are, let's say, creating kids that will be so easily replaced by machines. We are actually, as you have seen in some videos, the machines will be teaching the kids to do something the machines already do. So what is the purpose of all this? Are we short in time? Or, yeah? Oh. let me jump very quickly into this. I wanted to show you a project I'm working for writing scientific papers, combining LLM intelligence and human, so collaboration. The idea is to find collaboration, but I'm going to jump now into the idea of intelligence's ecosystem that I think it's very important. I wanted to show you, also talk about the different, what I believe are multiple and many and diverse manifestations of intelligences in the world. I'm going to jump that as well, but I think you get the idea nonetheless, down to the quantum foam, which is the most basic, smallest level of reality. You have information, computation, and maybe intelligence. So it's crazy. The line, if you read discussions about artificial intelligence, what's going on, you will see this line. You will see that, and this is kind of the stereotype we have of the idea people in general in this conversation have about intelligence. You have plants, you have the low animals, you have the cute animals that are more intelligent, and you have the humans, and the artificial intelligence is getting better. So at some point, it will get more intelligent than humans. This is more or less the discussion. A lot of problems here. Let's say the first problem we can see is that when you see how they define intelligence in humans, what are the arguments and what are the examples, it's always the same thing. It's technological and scientific progress as a way to show that humans are very intelligent, and that's already very problematic. But the problem is the line on itself. There's no line. There's never been a score for intelligence, and when you see people talking about this, more intelligent that, super intelligent, this kind of language assumes that we already agree with this line. And science without measure is not science, it's pseudoscience. All those discussions, pay attention to them, probably some of you already did, and you will see are extremely pseudoscientific, assume a lot of things, like we are already agree. There's nothing like that in science. Science every time looks into the system, science marvels by the infinite complexity of the system. And that's it. If you look into a cell, if you look into the behavior of birds, you will always find infinite complexity, interaction, exchange of information, even computation, and I call that as well intelligence, right? So if everything is infinite, it's not possible to actually have this idea that everything has already been measured in terms of insight. So one question, can we build machines that are more capable than humans? You will find this question here and there again. I see there is an inverse question mark here at the beginning, so this is like reading English with a Spanish accent. The answer to this is that every single machine we build is more capable than humans. If not, what is the point of building the machine? But still, this happens as if this was a real conversation, that it was relevant or important, like it doesn't mean anything. It's just, again. And while all this discuss, even to the level of talking about consciousness and things like that, this is what happens with our real intelligent and conscious cousins, right? And these are even the cute animals, so imagine. Right? What we do to them, imagine what we do today. So the ecosystem, I won't go into the details, no time for that. It doesn't matter because in reality, it's just an invitation to think about intelligences as things that are interconnected. Each intelligence or each kind of intelligence is different, interact with each other in different ways. Now that we have these crazy, fantastically good and interesting algorithmic linguistic intelligences interacting with us, etc., it's going to become more relevant to think about this as an ecosystem. All those systems are intelligent, right? From ecosystem to culture to life beings, algorithms, machines, etc. And we need to live in collaboration and not just in who is more than the other, right? Which is the first mental impulse for many, right? It's more about finding balance because we have crazy challenges regarding ecosystem. We have crazy challenges with machines and algorithms. We have crazy challenges everywhere. So the linear thinking won't help too much. I'm going to jump this idea of the LLM OS, but in short, it's crazy that now that instead of we having to talk as machines to machines, which was what was going on, coding is humans talking as machines to machines. And now it changed. And now it's the machines that talk as humans to humans. And that's fantastic. I love that. But this will have very deep transformation into the machine-humans ecosystem. To the point that now if you follow the conversation about agents need tools. Tools are other agents, and they communicate among themselves also using human language. Because the initiator was semantics, was human language. So it could happen that more and more machines will start using human language to communicate among themselves, bringing more complexity into the thing. I want to think, but before that, I want to show very quickly just an experiment I'm working on. Do I have 3 minutes for the last project? Okay. Kind of bringing all these ideas of multiple intelligences, agents that I just talked about, ecosystem, things interacting. So I'm going to play a little bit, and this is also kind of an education platform, maybe, I'm working on. So tell me a story about monkeys in Miami. Okay? So this is me. The monkey is me. And the parrot loves to talk. So the monkey says that to the parrot. And then the parrot will probably bring some story, and it's going to give it to the waiver. And indeed, you have the story, so you can read it. This is the story. Monkeys in Miami. The waiver is going to build a network out of this story. And it's going to bring it to the butterfly, which likes to visualize things. So this is, in short, this idea of agents. Algorithmic intelligence with agency, but also with kind of profile or even personality that are good at doing certain things. And if you start thinking in these technologies as a collaboration framework, I find that more beautiful as a new programming paradigm as well. So here you have Zooey, Max, Bella, and Charlie. The Miami Zoo, they go to South Beach, so I can actually, South Beach is one of the locations visited during the zoo adventure, and then Ocean Drive is one of the locations visited during the zoo adventure as well, etc. So all the things that happen between these monkeys, etc. A little bit more into analytics. The builder builds a data set. You ask for a data set, it builds it, and the analyst will look into the data and tell you think it has this profile of being a good analyst. So because I told the analyst, please help me. This is a table about countries where I want to live. Help me analyze this data set, and it gives you a full analysis, etc. And the last one, I don't even remember what it was. No, I was starting some new example, but it's more an invitation, even when building things with technology, to think more in terms of networks and collaboration, to take into account many other intelligence that exist in the universe and play with them. I'm going to be doing a workshop the following days, the coming days here in the university, and it's going to be about that. Playing, experimenting, etc., with the idea of intelligence. So that's it. Thank you very much.
So we are a little bit over time, but I think that I'm going to allow one question.
Okay.
Or two maybe. Yeah, go ahead.
Yeah, that's one question. I missed the first part of your presentation, but all those data visualizations, are you using the same tool to create the visualization, or use different tools?
I use JavaScript, and I build my own framework to build this kind of visualization and to do the analysis, etc.
No, you mentioned Studio.
Studio is, yeah, I also show things in Studio. Studio is a platform or a tool we build within my company, DroneWave, for other users to build things more easily without having to program, just connecting solutions. A little bit what happened also with the animals, a little bit this connectivity idea behind building data apps and stuff. Right?
Is that the same tool we use to build the data visualization?
Some of them, but some of them, yeah. No, the last one, no. The last one is JavaScript with my framework. Yeah.
There's another question.
I have a question. Thank you so much. So I really enjoyed the presentation, really, really good. I'm curious because you showed many tools and a lot of experiments comparing human communication and human language and machine communication. My question is, they're very different, right? You mentioned how the humans is more short, they're more smart, is a different type of intelligence. Do you have any type of studies of mixed conversations? Because now we're having more text interfaces, machine humans, and they're having that impact. So I'm wondering if you have any sort of studies or already some conclusions about that.
Yeah. Yes, I think one of the spaces where that has been researched the most is video games. With NPCs becoming more and more, having more agency, and with humans not recognizing NPCs from other humans, these kind of situations. So video games is I think is going to be the wildest place to look into human linguistic algorithms interaction. Yes, and I read a lot, and everything can happen. Because in a way it's very different indeed, and I pointed to some differences, but they are also extremely good at imitating humans. With proper, let's say, with proper profiling or context setting, it can become very good imitators as well. So it is going to create crazy situations for us. That's why I think it's an ecological kind of mental framework, what we need to better understand what is going to happen with technology.